Hello friends, welcome to engineering tutorial. So we will continue our discussion with television engineering, and in the previous videos we discussed about the basic introduction to television engineering and the basic concepts related to transmission and reception of the audio and video signals in case of TV. So before going into detail about the other aspects of television engineering, we must first understand some basic concepts related to the image, which is related to the video, because video is nothing but running images, moving images that are very fast moving images which appear as video. So we must understand some basic terminologies related to images, some of their characteristic properties, because these terms will come into play while understanding or while explaining various concepts. So we must understand what those terms are. So let us start. In this video we are basically going to cover intensity, aspect ratio, resolution, details and visual acuteness, some of those concepts, okay, related or revolving around these terms. Okay, so first is the intensity or light intensity. So there are several ways of measuring light intensity which are used in various fields of engineering, and each has its own definition and units. So for example, radiant intensity, which is the amount of energy which is unit in watts emitted per steradian, the angle, unit of angle. Luminous intensity, which is lumens per steradian or candela. Irradiance, watts per square meter, and radiance, which is watts per steradian or per square meter. Basically you will come around this unit, luminous intensity, in case of television or image processing. So luminous intensity, or sometimes it is also called as luminance, which basically you will this term candela will come into play. So the intensity of light in a picture, when we see a particular scene which is basically a picture frame or a image frame, the light, we can consider it as a source, and the light from it reaches our eyes. Basically we see a two-dimensional representation of a three-dimensional thing. We see it in 2D. Now there are various methods and technologies that have been adopted to give us a very good approximation of what a 3D experience is like, but essentially it is a two-dimensional representation because we are seeing it on a screen, flat screen or anywhere. So a particular scene on television, it can consist of variety of intensity of light and color which is emitted, okay, and these variations, or we can say fluctuations, it can be very fast, sharp in nature, or it can be continuous, gradually increasing or decreasing, or it can be slow. So these intensities, these are used to give various special effects and all of that. So the intensity of illumination, it can vary from very bright or to very dark, okay. So this is basically what we are trying to understand in terms of intensity of light in a particular picture frame or a image, okay. So the colors, that is in case of black and white. In colors we can also see various colors in the limits of the visible spectrum, from red to violet, each having its own wavelength values. So the rate at which this intensity of light varies or fluctuates, that is called as the frequency of variation. And generally in TV it varies from 0 to 5 megahertz, so that it has a soothing effect. Any more than that, it will be very disturbing, or it will not be very good to watch. Next, image or a picture frame. So as I said, video is nothing but moving images, okay, images that are moving or changing very fast at a very high frequency. So it is a two-dimensional representation on a plane surface. That is what a picture frame is, or an image is. So the various colors or light intensities that are emitted from the picture frame or the image, they form an image in the retina of the human eye. It is very much similar to a camera which picks up whatever scene is in front of it, which is within its frame, and forms its image on a photographic film. That is what we call a picture frame. Similarly, the human eye, it senses whatever happening is in front of it in terms of light intensity, in terms of color, whatever color it is there in front of it, and it forms an image on the retina. So whatever is within our field of view, that is called as the image or the picture frame for us. Whatever is within our field of view. Suppose we see a scenery. It is a much common scenery which we used to draw in it's a most common drawing, and please forgive my drawing skills, they are not very good, but I've tried my best. So suppose we see at a very good scenery, and this much portion is within our field of view, okay, of the human eye. So this much portion will form the image or the picture frame for us, okay. Now why this picture frame or image? That is very important, because another term associated with it, related to the picture frame or the image, comes, which is called as the aspect ratio, okay, the width to height ratio of a picture frame, which is very much important when it comes to the television screens that are used, which we have in our homes or anywhere. So for conventional TV screens, normally in old days, the standard definition aspect ratio, which is 4:3. It means the horizontal width is 4, means the ratio between the horizontal and vertical should be 4:3. This, okay, the horizontal is whatever it is, 4 times of a particular variable 4x, the vertical is 3x, the ratio should be 4:3. For high definition, 16:9 aspect ratio is used. But the dimensions of a TV screen are generally given in terms of the diagonal length, okay, this, and this can be calculated easily using Pythagoras theorem, okay. So the important thing here is the aspect ratio of the image or the picture frame, which is the width to height ratio, the ratio between the width of the screen and the height. Normally it is 4:3, sometimes 16:9 aspect ratio is also used. In today high definition TVs, we have 16:9 aspect ratio, normal it is 4:3. Now we have discussed about image frame, picture frame, aspect ratio. Now another important thing, which is the picture elements or pixels, okay. In the TV transmission and reception, in that video we have already discussed about scanning, how electron beam scans the image, whatever image is formed, and divides it into small picture elements, So this screen, let's say we have this screen, we have this image frame or picture frame. Now at the transmitter side we cannot send it as it is to the receiver side. No, it cannot be done like that. The camera, the TV camera, as we have already discussed, it divides it into very small picture elements which are the electrical equivalent of this image frame, like this. We divide it into very small picture elements. These small squares, they form the picture elements. For example, let's say this image, we have this image. Now we divide it into very small picture elements. Each of these small squares, actually the small squares are very small to be even visible to naked eye, but if we look closely we can just have a idea how these small squares are, they form. So again, as per the aspect ratio of the screen, the number of horizontal and vertical pixels, the ratio should be 4:3 or 16:9, okay, as per the aspect ratio. So each of these pixels or picture elements, they have their own characteristics in terms of intensity of light, color, the wavelength and brightness, all of those factors. So each of these small squares will represent a electrical signal. Okay, each of these small squares, pixels, they represent an electrical equivalent of the image. It can be represented in terms of voltage or current, and they represent a particular amount of intensity, light intensity, color, or brightness, whatever characteristics which we can attribute to an image. Contrast, everything will come into play. So these small picture elements are then transmitted to the receiver side, and various the modulation techniques are used. We know that for audio the frequency modulation is used, and for video amplitude modulation is used. Okay, so this is the division of this whole image into small pixels which are then transmitted. Now details and resolution. Okay, these small objects that are closely placed in, whenever we see a picture frame or an image, the small minute details, the more clear it is on a television screen, the more clearly we can pinpoint the small objects, the small details, the minute features in an image, the more better the detail or the resolution of that image is. Now this image, we can say, is a very good example of an image in which the resolution or the details are neglected. Why I am saying? Because whenever we look at a scenery, the mountains or the sky, it is not of one single color. It is not just one shade of brown here. Okay, it never happens like that. Each of these portions will have different shades of brown. Okay, not just one shade of brown. It can be sometimes very, bright intensity brown, and sometimes it will go one tone, it will drop one tone below, and it will have different shades of brown. Similarly, the sky, it is not just one shade of blue. It goes from light blue to a little bit one shade higher, one shade lower. Similarly, the trees, the green color is not just one shade of green. Okay, a very good artist will add various effects to it, and will try to take care of the details, the resolution as much as he or she can. Okay, so you can understand, okay, this image is not very good in terms of details and resolution, because it's just one shade of each color. Blue, it's just one shade. Yellow, the sun, it's not just one shade of yellow. There are various effects, details associated with it. Okay, similarly this house, it's just black. It's actually different shades of gray associated with it. Okay, so the more details or resolution is taken care of, the more we can pinpoint the exact, different shades of color of each and every object in the image. Okay, so details and resolutions, they are basically dependent on the number of pixels per inch of an image. Why it is important? Because when more number of pixels are added, then we have more choice. Okay, when more number of pixels will be there, then we have more choice of associating each pixel with different intensity, different color, okay, different brightness levels, to give more, to exactly replicate the image that we see on the screen. For example, see, suppose you take a picture, we click a picture with the help of a camera. For example, a mobile camera. The old days, the mobile camera which you used to shoot photos. Nowadays, where advanced level DSLR cameras are available. So if you compare the images of pictures which you used to click with older, old days the phones and today's phones and or DSLR cameras, you will find that the details, resolution, everything is better in today's cameras. Why? Because of these pixels. The more number of pixels are associated with per square inch, it gives us more choice. Okay, more choice to associate different brightness levels, different colors, to exactly replicate the image which we actually see with the naked eye. Exactly to replicate, not exactly, no camera will be able to completely replicate whatever we are seeing with the naked eye. Okay, nothing can replace the naked eye. So there will always be difference between the image that you actually see with your eyes and that on the photo, because the choices of camera is limited, but human eye can sense different infinite number of colors, wavelengths, brightness levels, but for camera it is fixed. No matter how good the camera is, it can never replace the human eye. Okay, so we can try to exactly replicate that image. We can never be able to completely do it with 100% efficiency. Okay, so that is what I'm trying to say. So the good cameras, they take into account the details and resolutions because of more number of pixels and more number of pixels per inch of an image. Okay, we have cameras with 64 megapixel and like that choices. We have 8 megapixel, 16 megapixel, 64 megapixel. So all these are related to that. So the resolution of TVs, that is very much in demand these days, the different types of high definition, standard definition, so all of these, they have these amount of configurations, the horizontal into vertical pixels. So the 720p will start from the bottom. It has a horizontal into vertical pixel 1280 into 7020, 1280 into 7020. The 1080 pixel, that is 1920 into 1080. This is the widescreen ultra extended graphics array, WXGA. Okay, that is 1920 into 1200, the horizontal into vertical pixel. Then we have the 2K, that is 2048, and this is unspecified. You will find mostly this will be written as unspecified. Then the ultra high definition UHD, that will be 3840 into 2160. Similarly 4K, it will be 4096. The vertical pixels will be unspecified. Then the 8K, which is 7680 into 4320. Okay, so this is all about details and resolutions. Another important concept which is related to the details and resolution, but this is related to from our side. Okay, from our side, the human eye, it has a resolution of the angle of 1 minute, which is 1 by 60 degrees. It means that if two objects, closely spaced objects, they form a minimum angle of 1 minute or 1 by 60 degrees, we can distinguish them. Okay, they will appear as distinctly visible. If the angle is any smaller than this, 1 minute or 1 by 60 degree, then it will appear as the two objects are getting merged. Okay, so this is from our side. So if two objects, they are 1 by 60 degree or 1 minute apart, then we can perceive them as two separate objects. So that is our visual acuteness. And another important thing is the viewing distance. Actually it has two main factors. First, the space between the objects, and the viewing distance. Okay, so let us say these two objects O1 and O2 are points O1 and O2. They have a distance of S, and from the eye it has a distance D. So the S by D ratio, that is very much important. Okay, and the angle between these two objects should have a minimum value of 1 by 160 degrees or 1 minute. Only then we can make out that these two objects are distinct. Next is the persistence of vision. Now this phenomena, it is also related to human eye. It is that when we see a particular image or a particular picture, it lasts, or it continues to form an impression on us, or we continue to see it for about 60 milliseconds. It is very, this time interval is very small, but it has a very important effect when it comes to television, because another phenomena, the flicking effect, that comes into play because of slight fluctuations in this time interval, the frame change interval. Okay, so it might seem as a very small time interval, okay, 60 millisecond, but it has a very huge role to play when it comes to that flicking effect of the screen. So the persistence of vision means that when we see it, but any image, whatever that comes in front of the human eye, we continue to see it for 60 milliseconds after that image is removed. Okay, so this property is exploited in the Newton disk. So that when this disk is rotated at a very high speed, because of persistence of vision, all of these colors, violet, indigo, blue, green, yellow, orange, red, okay, the 7 principal colors, that they because of this effect, they when it is rotated at a very high speed, they combine together to form and it appears that the whole disk is white. Okay, so this is a very beautiful effect or phenomena which is exploited because of this persistence of vision, this property. Okay, so the videos which are basically moving images or pictures, they use this, or they exploit this property of persistence of vision. So image frames, when they are changed in quick succession and the next frame is changed in less than 60 milliseconds, we feel that we are seeing a moving picture, or the image is moving. The video is basically moving images which are changed very fast, taking into account the property of persistence of vision. It should be less than 60 milliseconds. So when the image or any video, it consists of a multiple number of frames. So these frames are changed at a very rapid rate, and the frame change interval should be less than 60 milliseconds. Okay, so the display of each frame, it generally takes time in between 33 to 40 milliseconds as per the various television standards that are adopted across the world. So it basically is in between 33 to 40 milliseconds, which is very much less than 60 milliseconds. So I was talking about the effect, the flicker effect. So flicker is mostly it was in televisions, it was basically seen in black and white television. So flicker, it can be defined as the visible change in brightness when one frame is changed to the other. Suppose two frames, they have different brightness levels. One is very bright, basically it happened in black and white television. One frame is very bright on the white side and other one is from the black side, shades of gray in between, very bright, very black. So why flicker happened? Because the persistence of vision, that time, is more for a dark image than for a bright image. It means that when we look at a dark image, it lasts for a little bit more time as compared to when we see a bright image. So it appears as if the screen, the image frame, this kind of effect is produced. Okay, the flicker effect. So because of this, the dark intervals between the bright pictures, they become slightly visible and they appear, this effect. Okay, so the relationship between flicker and brightness, it is given by a particular law which is called as Ferry-Poster law, and is given by f subscript c is equal to f plus 12.6 log b to the base 10. So here fc, the f subscript c, is critical frequency at which flicker does not happen. B is the luminance of the picture, the luminous intensity, and f is a constant related to viewing conditions. Normally the f value is taken as 37. So it takes into account the various brightness levels, all of those things are taken into account to give a constant value, and it's normally taken as 37. So it is taken care that all of these parameters, they correspond to something which this critical frequency fc is, so that the flicker effect can be eliminated. Okay, so here we have discussed the various concepts related to image. We have covered the portion of intensity, aspect ratio and resolution. There are also other terminologies left, so we will discuss it in the next video. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.